Hello, Algebra 2, and welcome to Day 2 of Unit 2. We're starting inverses today with inverse relations and functions. A relation is a set of ordered pairs, like this set A. Relation A here, we have a set of 1, 2, 3, 4, 5, 6. And then A inverse, you just switch the x and y coordinates. So 1, 2 becomes 2, 1. 3, 4 becomes 4, 3. 5, 6 becomes 6, 5. Okay? Not too terrible to do. Why don't you go ahead and push pause and try to do B inverse. Welcome back. Let's see how you did. Okay, we're just flip-flopping x and y, so we should have negative 4, 3, negative 7, 1, and 3, negative 2. Okay, that is not a test question, but the idea of flip-flopping x and y to be the inverse is used in at least 2 types of test questions. Here's one of them. Finding the inverse function. Inverse functions undo each other or cancel each other out. F inverse of f, or f of f inverse, should cancel each other out and just leave x. How do you find the inverse function or inverse equation for a given function? So we are given f of x equals 2x minus 5. Okay, to get us started here, step 1, change f of x equals to y equals. Okay, that's the only thing that changed. Step 2, here it is, switch x and y. So we're going to flip-flop x and y, just like we do with the points up above. So now it's x equals 2 times y minus 5. Now we want to re-solve for that y. We're going to add 5 over and divide by 2. So we have x plus 5 over 2. And last but not least, we're going to replace the y with f inverse. Ta-da! So 2 times x minus 5, its inverse is x plus 5 divided by 2. You can kind of talk yourself through it here, that it should sound like, when you say it out loud, it should sound like opposite operations and in reverse order. So 2 times x minus 5. Opposite operations, reverse order. We want a plus 5 and then divide everything by 2. Okay? Are they inverses? Prove it. Okay, we're going to use our composition of functions to help prove it. And just like when we proved that matrices are inverses, if it works one way, you got to do it the other way as well. So we're going to do f of f inverse. That means we're taking f inverse and putting it in to the f equation. Okay, we're putting it in there. So we have 2 times x plus 5 over 2. Taking all that, putting it in for x. And then we have our minus 5. Okay, 2 times something that's divided by 2. Those 2's will cancel out. X plus 5 minus 5. Well, plus 5 minus 5 will also cancel out. And we're left with just x. Perfect. That's what it's supposed to do. They'll undo each other and just be left with x. It worked this way, so now we have to go the other way. F inverse of f. So we're going to take the f equation and put it in to the inverse equation. So we'll have 2x minus 5 plus 5 all over 2. Okay, we had a couple of these on Friday, or for our first lesson, where we had parentheses to kind of show where something was going in for x. but there's not a lot going on with the parentheses themselves. There's no 2 times, there's no negative, there's no exponent. So technically these parentheses aren't doing anything. So you could rewrite a whole other step without the parentheses, or I don't care if you just cancel these out right now. Okay? And now we have 2x over 2, which does reduce to just x. Yes. Inverses. And they are inverses because they undo each other or cancel each other out. That's very important to remember that. Okay. The back side is basically you trying it. So the first problem is just you coming up with the inverse equation, okay? So you might need to flip back and forth for those steps and examples. Alright, so you are going to come up with the inverse to this function. Go ahead and push pause and give that a shot. Alright, welcome back. So here's what we're doing. Step 1 is to change it to a y equals. Okay, step 2 is to switch x and y. X equals y over 3 plus 1. Step 3, we need to get that y by itself again. So we're going to minus 1 x minus 1 equals y over 3. And then we'll need to multiply both sides by 3. Alright, so we're going to have 3x minus 3 equals y. And your last step is to change that y to f inverse. And that will be your final answer there. 3x minus 3 equals f inverse of x. Okay, f of x, change that to y. Flip x and y, get y by itself. Change that y to f inverse of x. Okay, if f and x are inverses, then f of g cancels out to x, and g of f also cancels out to x. Okay, that would have been like the bottom problem when we tested those two out. Okay, except now the functions they're going to give you are like right there, instead of having to look up above. Alright? If it works the first way, you got to try the second way. If it doesn't work the first way, boom, you're done. They're not inverses. Okay? Go ahead and push pause and give it a shot. Alright, welcome back. Let's see how you did. F of g of x. We're going to take g of x and put it in to the f equation. So we have 3 times 1/3 x minus 3 plus 9. Okay, when I take that 3 times through, we'll get x minus 9. And then we have that plus 9. We just get x. Fantastic. But now we have to go the other way. G of f of x. You're putting the f equation into g. Okay, we got 1/3 times 3x plus 9 minus 3. Going to take that 1/3 into both, and that should drop us down to x plus 3 minus 3. Those will cancel, and we just have x. Yes, inverses, because they undo each other or cancel each other out. This one, what happens when I put g of x in to f? 2 times 1/2 x plus 2 minus 2. 2 times 1/2 will just give me x. 2 times 2 is a plus 4. And a plus 4 minus 2 does not cancel out. X plus 2. Not inverses. Okay, and once it doesn't work, you don't have to go the other way. All right. There you go, folks. Pretty short video. Okay, the worksheet that goes with this is also pretty short. So hopefully it's not too bad for you. Okay, thanks for watching. Good luck. Let me know if you have any questions.